Let us do a simulation with MOSFET and obtain the static curves of the MOSFET, just like we did for the BJT. So this time I will start it in a slightly different manner. What I will do is I will first create a folder, call that MOSFET. This is an empty folder. Now I'll go into the BJT. I'm going to copy only the schematic. I will copy bjt.schematic, copy, and then place it within MOSFET folder, and I will rename this MOSFET. Now when I double click on that, you see that the project file has automatically been created, MOSFET.project. So this is another way where you can start off from the work from your previous work. So this is the schematic that we have, and this is what we had used a version of this for obtaining the static curves of a transistor, a 2N222 transistor. So what we will do is remove this transistor and replace it with a MOSFET. Let me pick this component tool, click here, and I will type MOS. So there is a N-channel MOSFET symbol here. So here you see that it's a 4-terminal device. The substrate is not connected to the source. We need to connect the substrate to the source. So let me use this symbol. I will place it here, and I will click on this and remove the transistor symbol and move this and attach it here. Attach it here, and I'm going to join. I will use the wire and join the substrate with the source, and then I'm going to rename these labels. So this will be my gate label G, and this will be my drain label D. Ground is my source label. So otherwise all else will remain same. Now I have to change the model. So let me include the model for a MOSFET. So before that, let me name this reference as M1 for the MOSFET, and I will call it as some MOS device. For now we will take an arbitrary MOS device. So let me save this, and then I'll double click on this and let us put in a model for the MOS device. MOS device, and we call it NMOS. I'm going to change the DC sweep. V2 is the drain voltage. We can have drain voltage from 20 volts, 0 to 20 volts, 0.1 volt. Maybe I will make it 0.5 volts. And then V1 is the gate voltage. I'm going to sweep from 0 to 5 volts, steps of 0.5 volts. All else remaining the same, and I would like to see the drain current. So let us close that. So you see this is a model of this MOS device, the NMOS. I put a default NMOS device there, and then I am having DC sweep, V2 from 0 to 20 volts, steps of 0.5, V1 which is the gate voltage, 0 to 5 volts and steps of 0.5. Then run and then plot the drain current. So this is what we want to do. Let me save, and then I will generate the netlist. Go to generate netlist, spice, generate netlist. It will save it into mos.cir. So if I go to the folder, MOSFET folder, you have mosfet.cir here. So we have V1 which is the gate voltage, V2 which is the drain voltage. Don't bother too much about the values here because we are anyway going to give the DC sweep values, and this is the one which it will take. Then M1 is the MOSFET, and you see here drain, gate, source, substrate. They both are shorted together 0 0 because it was 4-terminal device, MOS device, the name. So the model for that MOS device is NMOS, and we run the program. So let me open the command window and let me go to that particular folder. So I am in the folder MOSFET ls. You can see that there is this MOSFET.cir which was generated, which you just had a look at that particular file. So let us simulate it. ngSpice MOSFET.cir. So this will run and execute, and these are the output characteristics or the drain curves as we call. Can expand that, and you can see that this is as expected and as we had discussed. But look at it that there is the drain current only microamps is flowing, and that's because of the default MOSFET characteristic. You can change the model of the MOSFET and you can obtain different values of drain currents. I can probably show that to you now. Let me quit this. I will exit from ngSpice and go back to the model. So I will change the model of this MOS device. So let me double click on this and I will change the model of this MOS device here. I have used an existing model of an NMOS MOS device here. Have put in these values into this and all else remaining the same. And so this is the model of the MOS device that I have put in there. And now let me save this and generate the netlist again. Once again, Spice netlist, generate netlist. It will save into mos.cir, save it there, and we can go back here and have a look at the mos.cir. You would get the new MOS device model here. Now let us simulate this one. We'll go here, ngSpice MOSFET.cir. You can see here that the value of the drain currents is much higher here, around 800 microamps compared to the default MOSFET. Can expand that and study these waveforms. And here this is the ohmic region near the low drain voltage value. X-axis the drain voltage sweeping from 0 to 20 volts, and y-axis is the drain current. I would like to show you, I will exit from here, one more variant here. I would like to use another type of MOSFET. Let us have a look at the ngSpice manual. If you go to the ngSpice users manual, this I have downloaded. You can Google it and download it from the net. So let me go to a page. So the contents, you see that there it is quite a detailed manual. It has 649 pages, and it is good for you to download it and study it in detail, or keep it by your side, and whenever you have doubt, refer to it for syntax. So this is a good manual to have with you. And I want to go to this page 156. In page 156 there is a model description of power MOSFET. Interesting. It's called vdmos device. And let me go to that page. So I'll go to that page. Here it is, page 156. in the ngSpice user manual, power MOSFET model vdmos. So this is a simple power MOS model which is given in specifically in ngSpice manual, which can be used and very effectively used. It's a good model. I will use one of the models that has been suggested here, this one. It is a P channel. I want to convert it into an N channel MOSFET and change the threshold voltage from -4 to 4, complementary, because I'm using an N channel MOSFET. So this is the model of a MOSFET. Observe here, only 3 terminals are there, which means that internally the substrate is connected to the source. So let me use this model. So I will copy this model and use it in our schematic. So I'll copy this, Control C, and use it in our schematic here. So I've copied and pasted it, but I want to change now the name to MOS device, which is what was there here previously, vdmos, and I want to change this one to N channel instead of P channel, and change VTO to 4, the threshold voltage to 4. So that's it, all else remains the same, and that is here. So M1 is a MOS device, but instead of 4 channel, I have to make it into a 3 channel, so I will have to take a different symbol. So let me do that. I will go back again here and I will type in MOS. There is one MOS device here, N channel MOSFET transistor, which is drain gate source, and this is the symbol, and let me probably take that one. I will take that and then place it here, remove this, delete, and move this into place. Alright, so now let me change the, let me change the reference to M1 as it was before. Don't want to change anything else, and the value was MOS device. That is the name that we have given, and this is a power MOSFET, 3 terminal device, drain gate source. And let us remove this wire. Yes, all else are same, and I will save this and again generate the netlist. Spice, generate netlist, store it into MOSFET.cir, save. So that is done. So when you go into the folder, MOSFET folder, MOSFET.cir, double click on that, and you will see the new MOSFET 3 terminal MOS device, which is here, and the model for this MOS device is the vdmos that we have taken from the ngSpice user manual. So this is the model. Only change that we made is we changed it from P channel to N channel, and the threshold voltage we changed it from -4 to +4. All else remaining the same, and let us simulate this one. So let me go back here and let me clear the screen and type ngSpice MOSFET.cir, and here you have the drain curves. So here you see here the drain curves. It is now in amps. This is reaching close to 5 amps. So this is a power MOSFET. So you see that you with different models you will be able to get different drain curves. I also now want to see what is transconductance curve. How do you do that? So let me now do the sweep only with respect to, I will keep the value of the VDD constant. So let me do the listing. So let me listing means list the circuit. See, VDD is V2, it is at 10 volts. We'll keep that fixed, and then V1 alone we will sweep. V1 is VG. So let me do a DC sweep of V1 from 0 to 10 volts in steps of 0.5 volts. So let us sweep that. So we have some data, and now plot. What do you want to plot? You want to plot the drain current minus IV2. Sorry, plot minus IV2. So this is the transconductance curve. So you see here at around 4, this was the threshold voltage, VGS threshold. So from there on, you see that there's a square law pattern coming into picture, and this is your transconductance curve. So it keeps on going to 95 amps from here on, from the after 4 volts of VGS. So this x-axis is VGS, y-axis is drain current. So this is how you get the static characteristics of the MOSFET, and I will put these files in the resources section, and you can download that and then use it, and then try to explore and learn more about the MOSFET and its static characteristics.